So they will be reacting with the water and this acid rains and all na. ஆசிட் ரெயின் எல்லாம் அப்படிதான் வருது. அவங்க வந்து அந்த இண்டஸ்ட்ரியில இருக்கிற எல்லா கேஸையும் வந்து இந்த CO2 NO2 இருக்கிற எல்லா நான் மெட்டல் ஆக்சைட்ஸோட கேஸஸையும் வந்து ionic character of MF will be more, because why ionic character they will be having, they altogether they will be having less size, so they will be having more character, ionic character MF, MCl, MBr, then Mi. Okay, M is actually a metal, monovalent metal. So if a metal exhibit more than one oxidation state, this is a very important point, children. Now reactivity towards the oxygen, they will be forming the oxides when they react with the oxygen, and there are two types, E2O3, and this E is basically that common formula I'm telling you. E means that is a particular hello students, எப்படி இருக்கீங்க எல்லாரும்? All good. So இன்னைக்கு ஒன் ஷாட்ல நம்ம எந்த சாப்டர் படிக்க போறோம்னா பி பிளாக் எலிமெண்ட்ஸை பற்றி தான் நம்ம படிக்க போகிறோம். பி பிளாக்ஸ் எலிமெண்ட்ஸே சொல்லும்போது வந்து நிறைய வந்து எக்ஸெப்ஷன்ஸ் இருக்கும், நிறைய வந்து மேம் இதில் எது படிக்கிறது எது படிக்காது, சில புக்ஸை பார்க்கும்போது யூ வில் பி ஹேவிங் ஏ லாட் ஆஃப் திங்ஸ் டு ஸ்டடி, நிறைய விஷயங்கள் படிக்கிறதுக்கு இருக்கும். ஆனால் கரெக்டாக ப்ரிசைஸாக சொல்லும்போது அதில் நான் அந்த அளவுக்கெல்லாம் படிக்கிறதுக்கு இல்லை. ஒரு என்ன சொல்கிறது, அதோட கெமிக்கல் ப்ராப்பர்ட்டிஸ் வேணும், அதில் கொஞ்சம் எக்ஸெப்ஷன்ஸ் இருக்குது, அவங்களோட அந்த ரியாக்ஷன்ஸு சில பேசிக்கான ரியாக்ஷன்ஸ், அவ்வளோதான். ஸோ அவ்வளோதான் அதில் படிக்கிறதுக்கு இருக்குது. பட் வாட் happens means you will get confused in some point where you can expect you can see a lot of topics in the P block elements. நம்ம வேற ஏதாவது சில புக் எல்லாம் எடுக்கும்போது நிறைய டாபிக்ஸ் இருக்கும். ஸோ நீட் as per the NEET அந்த அளவுக்கு நம்ம வந்து போகணும்னு இல்லை. ஸோ நம்ம இன்னைக்கு இந்த ஒன் ஷாட்டில் வந்து நம்ம வந்து இதை பற்றி படிக்க போகிறோம், பி பிளாக் பற்றி படிக்க போகிறோம். அண்ட் வி ஆர் ஆல்சோ லேர்னிங் த வாட் எவர் இஸ் நீடட். ப்ரிசைஸாக உங்களுக்கு என்ன தேவையோ அது மட்டும்தான் இந்த ஒரு ஒன் ஷாட்டில் நம்ம பண்ண போகிறோம். அண்ட் ஆஸ் ஆல்வேஸ் டெல்லிங் லைக் நான் வந்து இந்த ஒன் ஷார்ட்ஸில் கொஷின்ஸ் ஒன்றுமே டிஸ்கஸ் பண்ண மாட்டோம், அதுக்கு நம்ம லைவ் செஷன் தனியாக கொடுப்போம். எல்லா சாப்டருக்கும் போய் நம்ம ஒரு கிட்டத்தட்ட 3 சாப்டர் வந்திருக்கும், எந்தெல்லாம் சாப்டர் முடிஞ்சிருக்கோ அந்த சாப்டருக்கு எல்லாத்துக்குமே இருக்குன்னா கொஷின்ஸ் வந்து we will be discussing on the live session. Okay, so shall we start children? Okay, so first of all P block elements சொல்றது 13 to 18 வரை ஒரு நிமிஷம். Okay, 13 to 18 குரூப்ல 13 to 18 வர இருக்கிறது தான் பீரியாடிக் டேபிள்ல இருக்கிறது தான் என்ன சொல்றது, P block elements சொல்றது. And the P block elements will be having metals, metalloids, and they are non-metals also. This is very important. They will be consist of the metals, metalloids as well as the non-metals. There will be metals, there will be non-metals, and there will be the metalloids also. And general valence electrons is, this is very important, another very important point, ns2np126. ns2np126. So ns2np இதில் நம்ம இப்போ ஸ்பெசிஃபிக்காக நம்ம படிக்க போகிறது எதுன்னா, we are going to learn about, as in this particular one, we are going to learn about the 15 to 18. அது 15 to 18 வரை இருக்கிறது நைட்ரஜனில் இருந்து தான் நம்ம படிக்க போகிறோம். ஓகே, ஸோ ஃபர்ஸ்ட் ஆஃப் ஆல் before going to the periodic table, and one more thing I have to tell you here, there is an exception case which is helium 1s2. I told you that in the periodic table helium வந்து 1s2 தான், ஆனால் அது வந்து பீரியாடிக் பிளாக்ல இருக்கிற அந்த இடத்துல தான் போட்டிருக்காங்க. even though there is an s block element, அவங்க என்ன பண்ணியிருக்காங்கன்னா அந்த நோபல் கேட்டகரி இருக்குல்ல, நோபல் எலிமெண்ட் கேட்டகரி, அங்கே தான் அவங்க போட்டிருக்காங்க. ஓகே, அது மட்டும் நோட் பண்ணி வச்சுக்கோங்க. And there is another P block elements பற்றி படிக்கிறதுக்கு முன்னே இங்கே வர ஒரு நிறைய எக்ஸெப்ஷன்ஸுக்கெல்லாம் ரீசன் வந்து இனர்ட் பெயர் எஃபெக்ட் சொல்லிட்டு ஒரு என்ன சொல்கிறது ஒரு விஷயம்தான். ஸோ இனர்ட் பெயர் எஃபெக்ட்னா சிம்பிளாக சொல்லி கொடுக்குறேன். இந்த F ஆர்பிட்டல் D ஆர்பிட்டல் எல்லாம் வரும்போது உங்களுக்கே தெரியும் ஸ்க்ரீனிங் எஃபெக்ட் என்னென்ன. ஸ்க்ரீனிங் எஃபெக்ட் சொல்கிறது எலக்ட்ரான் ரிப்பல்ஷன் வரும்போது இருக்கிறதா ஸ்க்ரீனிங் எஃபெக்ட் சொல்கிறது. ஆமாம் தானே? S will be having more screening effect. S is greater than P is greater than D is greater than F. ஆமாம் தானே? DUFல வச்சு கம்பேர் பண்ணும்போது ஸ்க்ரீனிங் எஃபெக்ட் கம்மியாக இருக்கும். ஸோ ஸ்க்ரீனிங் எஃபெக்ட் கம்மியாக இருக்குன்னு சொன்னேன்னா their atomic size will be less. Am I correct? ஸோ அட்டாமிக் சைஸ் லெஸ் ஆகும்போது அவங்களோட S ஆர்பிட்டலுக்கு என்ன ஆகும் யோசிச்சு பாருங்க. அட்டாமிக் சைஸ் இஸ் லெஸ் மீன்ஸ் த S ஆர்பிட்டல் வில் பி இன்னும் நியூக்ளியஸில் வந்து அவங்க வந்து they will be attached more to the nucleus. ஸோ ஒரு கெமிக்கல் ரியாக்ஷன் நடக்கும்போது இல்லை ஏதாவது ஒரு ரியாக்ஷன் வரும்போது அதில் இருக்கிற அந்த S ஆர்பிட்டல், okay, so in the s orbital they won't be reacting. So that is called as inert pair effect. We can say that the neglectance of this ns orbital, or we can say that, okay, yes, due to the poor shielding effect of the intertwining the end of orbital, increased z effect hold the ns electron tightly and hence NS2 electrons do not participate in any reactions or bonding. So that is particularly called as the inert pair effect. Inert pair effect நால தான் நிறைய stability orders, oxidation state எல்லாம் வரும்போது oxidation state higher oxidation state இல்ல lower oxidation state இருந்தாலும் they won't be showing that particular oxidation state. It's all because of the inert pair effect. You have to know the inert pair effect before entering to the all the peculiarities or whatever we are going to discuss about the p block elements. அத பத்தி படிக்கிறதுக்கு முன்னாடி நம்ம inert pair effect குறிச்சு நல்லா you have to get an idea about it. So I repeat, what is inert pair effect? என்னதா இருக்கும் inert pair effect சொல்றது? See, இதுல வந்து இந்த ஒரு particular one won't be taking part in this, and here NS2 the here also, here this is I'm telling with 13 14 15 16 all the one is there. Here we are going to learn about, I mean, this one and this one. So reluctance of this all this particular NS orbital to take part in the electronic configuration, or not electronic configuration, basically in the chemical bonding, that is particularly called as the inert pair effect. Okay, now anomalous behavior. First of all, before going to this particular we are discussing and the p block elements and the in the nitrogen family, அத பத்தி எல்லாம் பேசுறதுக்கு முன்னாடி எல்லா p blocks இருக்குல்ல, இப்போ 15 16 17 குரூப்ல எல்லாம் நைட்ரஜன் கார்பன் ஆக்சிஜன் ஃப்ளோரின் ஃபேமிலில எல்லாம் ஃபர்ஸ்ட் எலிமெண்ட்ஸ் இருக்குல்ல, ஃபார் எக்ஸாம்பிள் கார்பன் ஃபேமிலி, நைட்ரஜன் ஃபேமிலி, ஆக்சிஜன் நைட்ரஜன் கார்பன், அந்த ஃபர்ஸ்ட் பர்டிகுலர் எலிமெண்ட்டுக்கு ஒரு அனாமலஸ் பிஹேவியர் இருக்கும். பேசிக்லி தட் அனாமலஸ் பிஹேவியர் இஸ் டியூ டு தேர் சைஸ் டிக்ரீஸ், லெஸ் சைஸாக இருக்கும். ஃபார் எக்ஸாம்பிள் இப்போ நைட்ரஜனை கம்பேர் பண்ணும்போது நைட்ரஜன் ஃபேமிலியில் நைட்ரஜனுக்கு தான் இருக்கிறதுல சின்ன சைஸு, ஆமாம் தானே? அந்த சின்ன சைஸும் அதே மாதிரி டி ஆர்பிட்டல்ஸ், அவங்களுக்கு டி ஆர்பிட்டல்ஸ் இருக்காது. They will be having the absence of d orbital and less size. Due to the atomic size is decreased and or less size and the absence of the d orbital in the first elements எல்லாமே they will be showing some peculiarity or some anomalous behavior. அது நம்ம வந்து டீல் பண்ணுவோம். Okay, so the first member of each groups from 13 to 17 of the pre-block elements are differ in many respective from the other elements or other members. Why that is the reason? It because of their small size, high electronegativity and their absence of d orbital. அவங்களுக்கு d orbital இருக்காது, high electronegativity when compared to the other elements it will be literally more, and also about the atomic size also. Okay, now the first member of the group has the greater ability to form as compared to other elements. See, basically what happens now, they can form the bonds between themselves. இப்போ நைட்ரஜன் ஆக்சிஜன் கார்பன், because they are forming p pi multiple bond. You will learn the p pi d pi and all in the chemical bonding chapter. I will continuously அதை பற்றி ஒரு நிறைய என்ன அது கரெக்ட், அது என்ன எப்படி நடக்குது எல்லாமே நம்ம கெமிக்கல் பாண்டிங்கில் படிப்போம். ஸோ பி பை பாண்ட் வந்து ஃபார் எக்ஸாம்பிள் கார்பன் அது கூடயே ஃபார்ம் பண்ண முடியுது. ஓகே, இட்ஸ் பேசிக்கலி பிகாஸ் ஆஃப் தியர் ஸ்மால் சைஸ். ரெண்டு பேருக்குமே ஸ்மால் சைஸ் இப்போ கார்பனுக்கு ஒரு கார்பன் இன்னொரு கார்பன் எடுத்தாலும் அது ஸ்மால் சைஸாக தான் இருக்குது, ஆமாம் தானே? அப்போ அந்த ரெண்டு ஸ்மாலர் சைஸ் கம்பேர் பண்ணும்போது ஈஸியாக இருக்கும். சைஸ் ஸ்மாலர் ஆகும்போது அந்த கார்பன் அந்த ஒரு பெர்டிகுலர் ஆட்டத்தோட சைஸ் கம்மியாக இருக்கும்போது கம்பினேஷன் வில் பி மச் மோர் ஈஸியாக. ஸோ வித் இட் செல்ஃப் அண்ட் வித் த எலிமெண்ட்ஸ் இன் த சேம் பீரியட் ஆஃப் த p block. So carbon oxygen கூட இப்போ இந்த கார்பன் ஆக்சிஜன் கார்பன் நைட்ரஜன் எல்லாமே சேம் பீரியட்ல தான் வருது. And carbon nitrogen oxygen, all this is possible because of this anomalous behavior of the first particular element in that whole group. Clear? This much is clear. Now next one is, so we are going to look into the group 15 elements. Okay, so you have the nitrogen, phosphorus, arsenic, antimony and bismuth in the 15th group elements. And this is very important. You have to learn about the name of the particular elements: nitrogen, phosphorus, arsenic, antimony and bismuth. So nitrogen and phosphorus are not considered as the non-metals. Okay, அவங்க ரெண்டு பேருமே non-metals, and arsenic and antimony is considered as the metalloids, and the bismuth is the metal. Okay, so you have to just have a note of this particular peculiarities also. That is also, I mean, அவங்களோட metals are non-metals அது கூட கொஞ்சம் பார்த்துக்கோங்க. Okay, next one is, so how their occurrence, we are going to look into the properties, a kind of properties. We can say that அவங்களோட occurrence எப்படி, atomic properties எப்படி, physical properties எப்படி, chemical properties எப்படி, இதெல்லாம் தான் நான் சொல்ல போறேன். இதுல ரொம்ப இம்பார்ட்டன்டான நிறைய விஷயங்கள் இருக்கு, கவனமா இருந்துக்கோங்க. Okay, now so atomic properties la varumbodhu you know the electronic configuration will be there, and you also know about this will be electronic configuration of the common electronic configuration will be there, and we will be discussing about the covalent and the ionic radii, and also we will be discussing about the ionization enthalpy, which is very very important, electronegativity, and also we will be discussing some groups, and all we will be also discussing about the electron gain enthalpy. Electron gain enthalpy ரொம்ப important. சில groups கன்சிடர் பண்ணும்போது electronegativity விட electron gain enthalpy is much more important. Okay. Okay, now first of all we are going to look into the electronic configuration. ரொம்ப bore அடிக்குதோ electronic configuration. So NS2NP3, see for example as per this particular 15th group nitrogen family, NS2NP3 is the common electronic configuration. What is the common electronic configuration? NS2NP3. So while we are checking about this atomic orbital, இப்படிதான் இருக்கும். Correct? NS2NP3 is a common electronic configuration, and here you can understand this particular NS is completely filled and this particular NP3 is half filled, or we can say that half filled orbitals are there. They are actually 6 is the maximum number of electrons which is in the p block. அவங்களுக்கு இப்ப எவ்வளவு இருக்கு? 3 இருக்கு சொல்லும்போதே நமக்கு சொல்லலாம் இங்க they have some extra stability, அவங்களுக்கு கொஞ்சம் extra stability கிடைச்சிருக்கு. Okay, this is all about the p block elements and the 15th group nitrogen family பத்தி தான் பேச போறோம். Okay, now first about the covalent and the ionic radii. This is very easy chapters written, கொஞ்சம் listen பண்ணா போதும், அந்த exceptions மட்டும் நோட் பண்ணிட்டேன்னா ஈஸி அந்த இந்த சாப்டர்ல இருந்து வர எந்த क्वेश्चंस வேணாலும் ஸ்கோர் பண்ணிக்கலாம். Okay, so covalent and ionic radii down the group மேலையிலிருந்து, see from down the group means if you are writing this particular one, just a second, nitrogen, you have the phosphorus and you have this arsenic, antimony, bismuth. From down the group what happens, you know that the ionic and the covalent radius will be increasing. Why they will be increasing? There will be addition of number of shells. Number of shells வந்து principal quantum number n வந்து increase ஆகிறதுனால ஷெல்லோட நம்பர் increase ஆகிறதுனால size வந்து என்னதா இருக்கும்? It will be increasing. Down the group the covalent radii from nitrogen to phosphorus increasingly considering, but arsenic to bismuth there is a slightly increase only. So when we are checking about the covalent radius particularly down the group, what happens means நார்மலா அவங்க இன்க்ரீஸ் பண்ணி தான் இருக்கும். ஆனா arsenic to bismuth, arsenic to bismuth, what happens? There is only slightly increase because of the, there will be only slightly decrease because of the poor shielding effect. Poor shielding effect நால shielding effect அந்த அளவுக்கு இருக்காது. So size வந்து அந்த அளவுக்கு increase ஆக முடியாது. Slightly தான் increase ஆயிருக்கும். So this is also a point you have to note it down. Okay. Next one is the ionization enthalpy. What is the general trend of ionization enthalpy? We have discussed in the periodic classification. Periodic classification நம்ம படிச்சிட்டோம். என்னதான் இருந்தது? Any idea? So what will be happening from top to bottom? Ionization enthalpy, am I correct? From top to bottom size increases, ionization energy decreases because they don't want to give that much energy to take the electron. அந்த எலக்ட்ரானை வாடா இங்க சொல்லிட்டு எடுக்கிறதுக்கு ரொம்ப எனர்ஜி எல்லாம் தேவையில்லை, சின்னதா வா போலாம் சொன்னாலே அவங்க வந்துடுவாங்க because they have that much size and the nucleus is not having that much attraction also. நீ போகாத தம்பி சொல்லிட்டு அவங்கள பிடிக்கிறதுக்காக அட்ராக்ஷன் எல்லாம் அவங்க கிட்ட இல்லை. ஸோ கண்டிப்பா அவங்க என்ன பண்ணுவாங்க, சரி நீ போய்க்கு என்னால உன்னால காப்பாற்ற முடியாது சொல்லிட்டு they will be taking. So when the size increases ionization energy decreases, right? So down the group atomic size increases, ionization energy decreases. Okay, this is very important and I hope you will be after இது இப்போ recording போகும், periodic classification முடிச்சதுக்கு அப்புறம் தான் recording போகும், I mean in the p block elements போகும். So you have to watch the periodic classification, then only you will be getting an idea about the p block elements, or else you won't be getting an idea. Okay, now so one more point I have to tell here, because there is a lot of questions. We will do the practice questions, PYQs. That time also you will be coming across a lot of questions like IE of the group 15 element NS2NP3 is always greater than 14th element. 14th element விட 15th element க்கு என்னதா இருக்கும்? IE கூடுதலா இருக்கும். 15th element means 15th group elements க்கு 14th group elements விட என்னதா இருக்கும்? நிறைய IE இருக்கும். It's because of what we have discussed, that is NS2NP3. P வந்து 3 ஆல்ரெடி இருக்கு. ஓகே இப்போ அதுலேருந்து ஒன்று எடுக்கணும். நான்லாம் கொடுக்க மாட்டேன், எனக்கு ஆல்ரெடி ஃபில்லாக இருக்குது, எனக்கு ஆல்ரெடி ரெண்டு பேனா மட்டும்தான் இருக்குது, நீ ஒன்று கேட்டுட்டேன்னா நான் மறுபடியும் என்ன பண்ணுவேன்? ஸோ இல்லைன்னா எனக்கு ஆல்ரெடி ஒரு பெண்ணு தான் இருக்குது, நீ ஒன்று கேட்டுட்டு நான் என்ன பண்ணுவேன்? ஸோ அதனால் வந்து they won't be giving it. So the ionization energy of this particular 15th element will be always greater than that of the 14th element. So this is the atomic size. Nitrogen is greater than phosphorus, arsenic, antimony and bismuth because of the extra stable half-filled orbital and the p orbital, the smaller size. This one, the reason for this one. Okay, next one is the electronegativity. We discussed about the electronegativity also. From the down this group, what happens to the electronegativity? It decreases because of the increasing in the size, and also metallic character also increasing na. So the electronegativity will be decreases. So as I told you, nitrogen will be having more electronegativity than phosphorus, then arsenic and antimony and bismuth. So in heavier elements, the difference is not that much pronounced. While considering the heavier elements now, they will not be having that much higher difference, which has to be, okay, this particular bismuth is greater, bismuth is lesser, bismuth will be having less electronegativity when compared to the antimony. Not that much pronounced or not much நமக்கு சொல்ற அளவுக்கெல்லாம் difference இல்லை. Okay, and one vision, like I will tell you one thing, after this particular discussion of this particular chapter, in the last one I will be giving you the end note about the properties, boiling point, melting point, and the group ella thodu. Okay, just like the solution I have given, just like that. Okay, now physical properties. Atomicity means all the elements of the group 15 are polyatomic. Polyatomic means they will be having more than 4 atoms, or we can say will be having more than 4 atoms. They will be joining atomicity. And metallic, when we consider the one second. Okay, state. So N2 is diatomic gas while all others are solid. Why N2 is diatomic? The reason, see, basically you don't want to know about the reasons of like boiling point exceptions or melting point exceptions or hydrides, they're forming hydrides form both exceptions or all exceptions. Exceptions first of all தேவையில்லை, but some exceptions I will be telling you, some exceptions I won't be telling you because that is not required for your syllabus. Since it is very precise to the syllabus, all the exceptions I won't be telling you. என்ன exceptions சொல்லிடுவேன், இது இப்படிதான் அதோட exception, அதுக்கான reason இருக்குல்ல, what is the reason behind that exception, that is not required for you. அது தேவையில்லை. ஸோ அதனால அது வந்து ஸ்ட்ரெஸ் பண்ணி சொல்லணும்னு இல்லை. பட் exceptions, what are the exceptions, I will surely, because அதுல இருந்தால் கொஸ்டின் வரும், அது எதுனாலும் I will be discussing with you. ஸோ N2 சொல்றது diatomic, அதோட ரீசன் என்ன சொல்றாங்கன்னா அதோட electronegativity value ஹையா இருக்கிறதுனால they will be forming diatomic because N the triple bond N gas அந்த state வந்து இன்னும் ஸ்ட்ராங்கா இருக்கும் சொல்றாங்க. Okay, so down the group metallic character increases. Metallic character increases means it will be having lesser with nitrogen and higher with the bismuth. Clear? Okay, next one is the physical properties. Here comes the exceptions of the boiling point and melting point, and you can surely accept a lot of question from this. Okay, so melting point generally what happens to the melting point is down the group, first of all we are discussing about the boiling point. Boiling point increases top to bottom down the group, BP increases, boiling point increases. Okay, so we expected like nitrogen, this will be the exception order, right? Accepted order: nitrogen, phosphorus, arsenic, antimony and bismuth. But Sb to Bi, there is a slight decrease in the boiling point due to the inert pair effect. So do you know what is the correct boiling point? One second. So this is the correct boiling point or point order of the particular nitrogen family. Nitrogen is lesser than, phosphorus is lesser than, arsenic, then come the bismuth, and then come the Sp. Okay, here also see this is the particular one. Nitrogen is lesser than, phosphorus is lesser than, arsenic. Then they are telling about the bismuth. Bismuth is actually great, bismuth. Antimony is actually greater than the bismuth. So I have given the two order also. This like this also they can ask in the question, and this is the correct order also for your understanding what is happening. Actually, if you are not getting this particular point na, adu enna solranga na arsenic vida kammi da, arsenic வந்து less than da, இத compare பண்ணும்போது antimony compare பண்ணும்போது, but antimony is greater than the bismuth. So it will be first will be bismuth, then antimony. Clear? Okay, now comes the melting point. Down the group melting point also increases as in the boiling point. Melting point also increases from N to A, then decreases from As to Bi. This is the one. See, nitrogen, phosphorus, what happens means after before arsenic you will be having bismuth. okay, then antimony, then arsenic. This is very important one, children, about the melting point of this particular nitrogen family. They can ask you the question. Melting point. This is exception, okay? Which is very, very important. Very important. Okay. Okay. Now, physical properties, allotropy is there. Allotropy means basically like it is a phenomena in which one substance can... What is allotropy basically? It is a phenomena in which we can say that the one substance will be existing in the different physical form, right? So, if we are telling like all the elements except the nitrogen due to their properties, I told you, d orbitals, less size, more high electronegativity and all anomalous behavior, all the elements except the nitrogen shows the electronegativity. I mean allotropy, not electronegativity, allotropy. So, example, phosphorus can in the wide range of the allotropic configuration, red, black, white, phosphorus and all. And three most significant allotropic structure are red, black and white phosphorus. Allotropic structures are arsenic. Arsenic or the black, grey and yellow. And yellow, metallic and explosive are the three significant allotropic of the antimony. This question but still you can have a note of it. இதெல்லாம் எழுதி வச்சுக்கோங்க, அந்த டைமில் ரிவைஸ் பண்ணிக்கோங்க. பட் மெல்ட்டிங் அண்ட் பாயிலிங் பாயிண்ட் யூ ஹாவ் டு கீப் இட் வெரி ரிவைஸ் பண்ணி ரொம்ப உங்கள் மைண்டுக்குள்ளே இருக்கணும். அது ரொம்ப இம்பார்ட்டண்ட். Okay, now anomalous behavior of nitrogen. You know that nitrogen anomalous behavior recent, right? So the catenation tendency is weaker in the nitrogen due to the weak NN single bond. Nitrogen form p-pi multiple bond. So what happens means they will be forming the compounds with the nitrogen and nitrogen, but they are little weaker. They will be forming when compared to the other elements and all, phosphorus, arsenic and all, but they will be having little lesser due to the NN. I'm not telling NN weak bond. Okay, so they will be forming p-pi multiple bond with itself and other elements, whereas heavier of the same group can't have. So nitrogen வந்து பண்ணுவாங்க, ஆனா other elements க்கு வந்து see they will be forming like their catenation tendency in is weaker in nitrogen due to the weak. They will be forming. அவங்க அந்த catenation சொல்றது என்னது? என்ன catenation? இது எல்லாமே சொல்லிட்டு நான் அது சொல்லாம இருந்தா பாரு. Catenation சொல்றது என்னது? What do you mean by catenation? Catenation, we can say that it is the ability of the form of an element to form the bond with themselves. Okay, அதுதான் catenation சொல்றது. So catenation tendency சொல்றது அது வந்து கொஞ்சம் வீக்கா இருக்கும் nitrogen because of their d-pi multiple bonds. So it will be little weaker in the nitrogen, but they do form. But other elements in the nitrogen family, they cannot. So another factor that affects the chemistry of the nitrogen is the absence of the d orbital, which we have discussed already. They don't have the d orbitals, that is 2s2 2p3 now. They don't have the d orbital, but other elements in the nitrogen family will be having the d orbital. Next one is chemical properties. Chemical properties, that is oxidation. We will be discussing about the oxidation trends, what will be happening in there, how this inert pair is actually working there, and we will be discussing about the reactivity towards the hydrogen, how they are forming hydrides, and we will also discuss about the oxides, halogens, metals, everything. So metals we won't be discussing, but we will be discussing these through metals also. Like we will be just discussing only because that is not that much important in the exam oriented view, but these are very important ones. Okay. So next we are going to discuss about the first one is the oxidation state. Okay, now as I told you in the chemical property, first one is the oxidation state of the group 15 element. So the common oxidation state, the common oxidation state of the group 15 is -3, +3, 2 and +5. This is the very common oxidation state of the group 13 or 3 children. Group 3 da solittu irundholla. Group 13. Common oxidation state of the group 15. Group 15 elements, that is nitrogen family. Okay, not group 13, group 15. Group 13 is boron. Group 15 is -3, +3 and +5. So stability of the -3 oxidation state. Stability of the -3 oxidation state. I repeat, stability of the -3. Okay. அது என்ன ஆயிடும்னா it will be decreases down the group. So நைட்ரஜனுக்கெல்லாம் தான் நைட்ரஜன்ல இருந்து நைட்ரஜன் பாஸ்பரஸ் ஆர்சனிக் அது கீழே வரும்போது அந்த -3 சொல்றது ரொம்ப ஸ்டேபிளா இருக்காது. So nitrogen will be forming -3 oxidation state more when compared to the bismuth and antimony and all. Okay, stability of the +5 oxidation state decreases down the group. +5 oxidation state decreases. Yeah ma'am, +5 oxidation state decrease ஆகுது. Any reason? இங்க தான் நாம சொன்னது வர போறோம். Any reason why the stability of the +5 oxidation state is decreasing? +5 oxidation state is decreasing. It's because NS2NP3. NS2NP3, right? We know that when top to bottom, when it is coming, the NS orbitals will be having that reluctance to take part in the bonding. Right? So what happens means this particular one will be taking part, but this won't be taking part. So that is the reason why the stability of the +5 oxidation state will be decreases down the group. This is also very important due to the inert. வேற ஏதாவது கலர் ட்ரை பண்ணலாமா? என்ன கலர் யூஸ் பண்ணாலும் நல்லா இல்லையே. Due to the inert pair effect. Due to the inert pair effect, the stability, this is I, children. Inert pair effect, that is the reason why the stability is decreasing. +5 stability. Okay, so the order of the stability will be +5 phosphorus, arsenic. See, listen here, children. Now you will be order of the stability of the +5 oxidation will be lesser for the bismuth. But this is the order of the stability. There is another character, or there is another, not character basically, there is another compound which is actually called as BIFI. Now you may think that, ma'am, B5 சொல்லும்போது bismuth சொல்றது கீழே வருது. So அந்த stability கம்மியாகும் நீங்க சொல்லிருக்கீங்க. +5 stability will be very less when come to the bismuth and all, and this is the order also. Of course, this is having a less value, but BIFI is possible. This is very important question, children. This is a very important question and a very important point which they can ask you. This is possible. They can ask you, is BIFI is possible? Now you may think that, okay, BIFI means the bismuth is having a +5 oxidation state. So ma'am told that +5 oxidation state now they won't be possible because of inert pair effect. There is an inert pair effect, that is not like, it's not that the inert pair effect is not there or something, but what is happening here is, here if fluorine is here, am I correct? Fluorine is here. Due to the presence of the fluorine, which is a highly electronegative atom, and the bond வந்து அவங்க stabilize பண்ணுவாங்க. ஓகே, என்ன ஆயிடும், அந்த fluorine கூட இருக்கிற அந்த 5 பாண்ட் இருக்குல்ல பிஸ்மத்துக்கு, அந்த பாண்டை வந்து they will stabilize due to the high electronegativity. From this high electronegativity, fluorine-ஓட high electronegativity-னால they will stabilize that particular bond, and they will be helping, or they can form the BIFI. This is very important question. They won't be asking you like அவங்க வந்து இதோட ரீசன் என்னன்னு கேட்கறதுக்கெல்லாம் சான்ஸ் கம்மி தான், but they will be asking in such a way that which are the statements are correct. So they will be giving a statement like BI5 is not possible. It's because of the +5 oxidation state of Bi is very less stable. So BIFI is possible, not possible. It is possible. It's an exception case. Okay. Okay, next one is the other oxidation state nitrogen except with the large number of oxidation state +3 to +5. They will be showing +3 to nitrogen will be showing more oxidation state +3 to +5. +3 through +5. Okay, so when they react with the, see, especially this -3 to +5, this will be showing that whenever they react with oxygen, not +3, -3 to +5, whenever they are reacting with oxygen, they will be showing it more. See, nitrogen in the ammonia it is in the state of -3. We will discuss about the oxidation. You know how to find the oxidation rate. If it is not, we will discuss in the redox reaction. After the chapter, probably we will be taking the redox reaction. Okay, N2 will be oxygen 0, N2O will be +1, NO +2. So this will be like, this will be 2 and this will be 2. Likewise, N2O3 means +3 will be the oxidation state. Here N2O4 and NO2 will be +4 oxidation state. N2O5 +5 oxidation state. So this is basically what happens here is like during the particular -3 to +5 is usually happening when they are forming the compounds with oxygen. So they do have the -3, 0, +1, +2, +3, +4, +5 oxidation state when it is coming a when it is react with the oxygen. Next one is nitrogen does not form the compound +5 oxidation state. Do you know why? This is also another important point. You have to make a note of it. Nitrogen does not form the +5 oxidation state because it does not have the d orbital. See, and the excitation நடந்து 2s2 2p3 இருக்கிறதுல இருந்து அந்த 2s ல இருந்து excitation நடக்கணும். அப்பதானே எல்லாமே ஃபார்ம் ஆயிடும். அதுக்கு அந்த எக்ஸைட்டேஷன் நடக்கிறதுக்கு அந்த எலக்ட்ரான்ஸ் போகிறதுக்கு அங்க இடம் இல்லை. So there is no what to say, there is no vacant or there is not even having any d orbital. So that is the reason why there is no +5 oxidation for the nitrogen. Okay, so reactivity towards the hydrogen, all the elements. Now you may think that ma'am +5 oxidation illa, but see, +5 oxidation state soldier very less stable, unstable. See, very unstable. See, that's why bismuth when they are telling that particular +5 now, they are just giving it in this end. Okay, next one. One more thing point you have to note here. Phosphorus is there now. Phosphorus will be showing this +1 and +4 oxidation with the oxo acids like hypophosphoric acid, phosphorus acid and all. And they will be showing different oxidation state like +4, +1 and all. So that is also another point. They can show +1 and +4 also. Okay, so reactivity towards the hydrogen. Hydrogen, you know that every elements, all the elements will be forming the hydride with this particular, they will be forming hydrides when they react with the hydrogen. See that the common formula is CH3. For example, NH3, PH3, all this is possible. I will ask you a question here. Okay, that question we will discuss in the live session. Okay, now properties of the hydrates. This you have to take a note of it. You don't want to know the reasons and all, but make sure that you are noting down this particular order, stability order. Okay, hydrides order, hydrogen கூட react பண்ணிட்டு வர அந்த hydrides order stability order தான் சொல்ல போறோம். NH3 is greater than, PH3 is greater than, arsenic ASH3 is greater than, SBH3 is greater than, BiH3. This is the stability order. Reducing character, basicity order. Reducing character சொல்லும்போது நைட்ரஜனுக்கு கம்மியா இருக்கும், பிஸ்மத்துக்கு தான் அதிகமா இருக்கும். Because they will be having more size now, this will be having less size. Basicity order also, NH3 is greater than, PH3 is greater than, ASH3 is greater than, SBH3. Because BiH3 will be having more acidic order, because acidity order, the acidity வந்து அதுக்கு அதிகமா இருக்கும். ஏன்னா the size increase ஆகும்போது ஹைட்ரஜனை ரிமூவ் பண்றதுக்கு ஈஸியா இருக்கும். பட் ஹியர் என்ன ஆகுறேன்னா பேசிசிட்டி அதோட நேரம் ஆப்போசிட்டா இருக்கும். ஓகே, now oxygen order reactivity, this is very important. Okay, now reactivity towards the oxygen, they will be forming the oxides when they react with the oxygen, and there are two types, E2O3, and this E is basically that common formula I'm telling you. E means that is a particular 15th group element. Okay, so E can be nitrogen, phosphorus, arsenic, antimony and bismuth, and but nitrogen forms various other oxides like NO, NO2, N2O. I told you there is a lot of anomalous behavior of the first element in the group, so they can form other oxides also like NO, NO2, N2O3, all those things are N2O, all those are possible for the nitrogen. Next one is reactivity towards the halogen. How they will be reacting with the halogen. Halogen reactivity. So first one, these elements react with the halogen, and of course they will be forming the halides. Halogens means fluorine, chlorine, bromine, iodine. Okay, EX3 and EX5 is the state they will be forming, and EX3 will be forming for the nitrogen, phosphorus, all the elements. But what happens, EX5 won't be forming with this particular nitrogen because nitrogen does not have the d orbitals. So EX5 is not possible. Even Bi also will be forming with the halogen, because it's because of that particular high electronegativity of the halogen, they will be stabilized it. That particular bond formation will be stabilized, and this is possible for Bi. But here it is not possible. Nitrogen is not possible due to the absence of the d orbitals. This is very important point. Okay, next one is reactivity towards the halogens. How they will be reacting. So these elements like EX3, EH5, as I told you, like nitrogen, phosphorus and all, this except this NXX5, all the other will be forming EX5. Halides are forming EX3, ENX5, except NX3, all trihalides are stable. EX3 is not that much stable because they have the nitrogen is actually have the they have the small size, and in that small size the chlorine is coming. I mean chlorine or whichever is the halogen is coming, they are not that much stable, but all other trihalides, because they have little more higher size now, they are stable. Except nitrogen, all other form pentahalides. Why nitrogen is not forming? It is having the absence of d orbital. Pentahalides are more covalent than the trihalides. Order of the stability of the halides will be, of course, fluorine is greater than, chlorine is greater than, bromine is greater than iodine. Next one, group 16. Now we have done with the particular boiling point, melting point, everything about the group 15. Now we are going to look into the group 16. Okay, group 16 means group 16, oxygen, sulfur, selenium, tellurium and polonium is the elements which is in the group 16, and this oxygen and this particular oxygen and the sulfur considered as non-metal, selenium and tellurium considered as the metalloids, and the polonium will be having, it's a radioactive metal, and this is also very important point, children. They are called as chalcogens. Okay, polonium is a radioactive and it is a short-lived compound, or not compound basically. It's an element. Okay, it's a radioactive and short-lived. Now oxygen, when we consider about the oxygen, these are very just what happens, what is actually the oxygen, all the peculiarities. Okay, they are the most abundant elements. Oxygen is the most abundant element, and it exists in the free form as O2 and makes up to 20% by volume and 23 by weight of the atmosphere. Most of the oxygen is widely produced by the photosynthesis. So they are getting it in the photosynthesis. We will be getting more oxygen in the atmosphere. When come to sulfur, 0.003 sulfur, 0.034% of the weight of the earth crust, and occurs mainly in the combined form as the O's or sulfates. O's means, which we know that when we will be taking that particular metal, that mineral which is suitable for taking that per extraction of the metal, that is called as ore. So it is combined in the form of it won't be in the free state, it will be combined form. So that Epsom salt, galena, gypsum, all these are example which is having the sulfur one. Next one is that two slides was actually to get an idea about it. Okay, next one is the atomic properties, not orbital children, atomic properties. In the atomic properties, you have your electronic configuration, ionic and atomic radius in the nitrogen family, also ionization enthalpy, electron gain enthalpy, electronegativity. See here, electron gain enthalpy is coming, but not in the nitrogen family. Okay, so here electron gain enthalpy also will be discussing, because there is a lot of questions which is asking from that also. So they will be having 6 electrons on the valence shell, that's why ns2 1 np6 it will be, and the general valence electron configuration is ns2 np4 it will be, because there will be having 6 electrons, and ns2 np4 it will be having. And atomic radius, when we are telling about the atomic radius, oxygen, sulfur, selenium, tellurium. Polonium we won't be considering that much when it comes to the atomic orbitals, because atomic radius, because they are short-lived and radioactive now. So usually when we are telling about, we will be discussing about this 4 only, but yeah, in some cases and all in the melting point and boiling point and all, appo vandu nama vandu use pannuvom. Okay, so atomic and ionic radius means oxygen, sulfur, selenium and tellurium. You know that from top to bottom what happens to the atomic radius, increases, right? So down the group, the atomic and the ionic radius increases due to the increase in the number of shell. So here you want to make a note of it, like electronic configuration ns2, it is having the 6th, it comes under the category of the 6th group 16th element now. So 6 electrons will be there, ns2 np4 will be the electronic arm and electronic configuration will be, and ionic and covalent radius will be increasing down the group due to the increase in the number of shells, same like in the nitrogen family only. Okay, ionization enthalpy, when checking to the ionization enthalpy, what is the peculiarity? What is the peculiarity of the ionization enthalpy? Ionization enthalpy means it is the how much electrons is required, how much energy is required to take that outmost how much energy is required to take the outermost shell electron எடுக்கிறதுக்காக என்னன்னா ionization energy சொல்றது அம்மாதானே. ஸோ ஆஃப்கோர்ஸ் சைஸ் இன்க்ரீஸ் ஆகும்போது ionization energy டிக்ரீஸ் ஆனால் போதும், கம்மி எனர்ஜி கொடுத்தா போதும். ஸோ ஆக்சிஜனுக்கு தான் நம்ம வந்து ஆக்சிஜனோட சைஸ் தான் கம்மியாக இருக்கும். ஸோ they will be having more ionization energy and tellurium will be having less ionization energy because they will be having more size, more size and less energy. Okay, so and group 15 16 நம்ம கம்பேர் பண்ணும்போது see அந்த டைமில் நான் சொல்லியிருந்தோம்ல like 15 will be having more ionization energy because it's half filled and this will be having less ionization energy because ஒன்று கொடுத்துட்டு போங்கடா போயிட்டேன்னா எனக்கு NP3ல இருக்கும், NP4 தானே இப்போது NP3ல இருக்கு, NP3ல இருந்தால் இன்னும் எனக்கு ஸ்டேபிள் ஆகிடும், அப்படி தான் நடக்குது. ஓகே, group 15 elements have high ionization enthalpy because of the extra stability of the half filled p orbital or p subshells. Okay, now electron gain enthalpy, I want you to here note down, this is very important point. There have been a lot of questions which is asking from this point also, electron gain enthalpy. So you know that electron gain enthalpy means it is the energy released or accepted when we are giving, we have discussed that positive electron gain enthalpy இருக்கும், negative electron gain enthalpy இருக்கும். எலக்ட்ரான் நம்ம போடும்போது ஒரு எலக்ட்ரான் நம்ம வந்து இப்போ CL இருந்ததுலேக்கு ஒரு எலக்ட்ரான் வரும்போது அதோட எனர்ஜி தான் எலக்ட்ரான் கெயின் enthalpy சொல்றது. CL மைனஸ் ஆகிறதுக்கு ஆனியான் ஆகிறதுக்கு எனர்ஜினா தான் எலக்ட்ரான் கெயின் enthalpy சொல்றது, ரைட்? ஸோ we also discussed that down the group what happens down the group of electron. See, we will be telling that down the group electron gain enthalpy will be decreasing, am I correct? So for oxygen, see, due to the compact nature it has less electron gain. What happens means we will be explaining like நம்ம என்ன நினைப்போம்னா oxygen is greater than sulfur is greater than selenium is greater than அப்படிதான் போகும்னு நினைக்கும். ஆனா இங்க electron gain enthalpy there is an exception. This is exceptions of the particular electron gain enthalpy. See, this is exceptions which we நம்ம expect பண்ணது இன்னொன்னு, expected இன்னொன்னு. Okay, so what happens means sulfur is greater than selenium is greater than tellurium is greater than oxygen, less for this particular oxygen due to their smalls, அவங்களோட small sizeனால என்ன ஆயிடும், they are not ready to accept more electrons because they themselves is having a lot of repulsion. அவங்க electrons repulsion இருக்கு, அதுல இன்னொன்னு add பண்றதுக்கு they are not ready. Okay, so that is the reason why they will be having less electron less energy or less value for the electron gain enthalpy. So from top to bottom it will be decreasing. So we expect that oxygen will be more but it will be having less because of their small size and the acceptance of the electrons or addition of electrons is really difficult. Clear? So due to the compact nature it has less electron gain enthalpy. Okay. Now electronegativity also from top to bottom what happens, that will be decreasing. So oxygen will be having more electronegativity when compared to the all other elements, selenium, tellurium and polonium. So from the top to bottom it will be decreases when there is an increase in their atomic size. So now as I told you about this particular one second, this electronegativity, now we expected that this particular one will be in the order of oxygen, sulfur, selenium, tellurium and polonium. This is the expected one we will be thinking this will be happening. But usually நிறைய டெக்ஸ்ட் புக்கில் வந்து இது கொடுத்ததில்லை, நிறைய டெக்ஸ்ட் புக்கில் நான் பார்த்துருக்கேன். But I want you guys to note down this particular one. Between sulfur and the selenium there is a difference. செலீனியத்துக்கு தான் they will be having there will be having an exceptions between the sulfur and the selenium for the electronegativity. Selenium will be having more electronegativity when compared to the sulfur because of their less size. ஒரு unexpected size decrease வந்து sulfur selenium compare பண்ணும்போது இருக்குது. So அதனால reasons எல்லாம் like it's not needed that much but I'm just telling you for your knowledge. So அதனால oxygen is greater than selenium is greater than sulfur, tellurium and polonium. This is the order of the particular electronegativity. This is an exception, taken out of it. Okay, next one is the physical properties. Down the group what happens to the physical property, the metallic character increases due to the increase in the atomic size. When the atomic size increases metallic character also increases. And down the group the catenation catenation is decreases. Down the group, the catenation power will be decreases. That's why carbon is forming, but nitrogen is also forming, but it's not that much. They are not supportive to form the phosphorus which next elements carbon oxygen sulfur they are not ready. Okay, they are not supporting that particular one. So down the group catenation decreases, but sulfur again for the 16th oxygen family, sulfur will be having more catenation, or they have the ability to form the higher catenation than the oxygen because of their repulsion. So the sulfur is having the ability to form the catenation because of their oxygen repulsion. So they will be having more catenation power when compared to the oxygen. Sulfur catenation is more. Even see, usually nama paathirukra pattern enna nitrogen la irukattum in boron nama the boron family carbon family எல்லாம் வரும்போதா இருந்தாலும் catenation வந்து கம்மி ஆயிடும். But here என்ன ஆகுறேன்னா sulfur catenation இன்னும் கொஞ்சம் அதிகமா இருக்கு because of oxygen கூட catenation பண்றதுக்கு அந்த repulsion வருது. So oxygen they are forming the catenation, but when compared to the sulfur it is lesser in the amount. Okay, boiling point, here also there is an exception which is very very important. So in the exception இவங்க எழுதிருக்கிற மாடல் ஒரு படி இருக்கு, உங்களுக்கு அது கொஞ்சம் டிஃபிகல்ட்டா இருந்தானா இது பாத்துக்கோங்க. See, boiling point, what we expecting is what will be happening, it will be increases. So we expected that, okay, from top to bottom what we expect is it will be increasing. Top to bottom we expected that to be increases for the boiling point, but what actually happens is it will be, see, oxygen is lesser than, it is increasing only. When comes to the polonium and tellurium, what happens, there is an exception here. Correct, there is an exception here, so that I have written in the like avanga rendu pere paathumbodhu poloniyathukku da we expect that polonium will be having more boiling point, but it is not the case, Te having more boiling point. So this will be the another exceptions which you have to take a note of it, which is very very important. Boiling point. Next one is melting point. Melting point also same boiling point and melting point having same exceptions, and the reason behind that is inert pair effect because of this particular reluctance of this NS orbital or S orbital, they are not taking part in the bond formation. So that is the reason why this, instead of the polonium which has supposed to show high boiling point and melting point, they are showing less when compared to the tellurium. Okay, so this is also another important boiling point and melting point. I will write a cheat sheet at the end of this chapter, after the chapter, by picking another slide I will write it down, but still this is also very important. Okay, all the elements show allotropy. So when compared to the properties, physical properties of the oxygen family, they will be showing the allotropy will be the allotropy. Oxygen exists in the two allotropic forms, that is O2 and the O3. Dioxygen, which is O2, which is the breathing oxygen which we are breathing, and O3 will be, it's unstable actually, basically it is unstable when compared to the O2. So what happens means they will be unstable and decomposes and they will be forming the O2. Okay, now general trends and chemical properties. So down the group, okay, when down the group, what happens to this -2, they tendency to exhibit -2 oxidation state decreases, just like the -3 na, -3 in the nitrogen, the -2 is decreases. Down the group, the tendency to exhibit +4 oxidation state increases due to the inert pair effect. So NS2 NP4 was the electronic configuration, and when coming down the group, what as an NS will not be taking part, they will be having I cannot ennala mudiyadunu irukra oru situation varum. So NP4 or the +4 oxidation state will be increasing. This is very important point due to the inert pair effect. So down to the group, tendency to show the +6 oxidation state, that will be decreasing because of this same inert pair effect. Next one is the chemical properties, which is a reaction towards the hydrogen, reaction towards the halogens, and reaction towards the oxygen. Same oxygen reaction towards the halogen and oxygen. So next one, the properties of the hydrides la pathina thermal stability பத்தி, அது next stability factor வந்து thermal stability பத்தி நம்ம இந்த மாதிரி acid இந்த ஹைட்ரைட்ஸ்ல இருக்கிற thermal stability பத்தி தான் நம்ம பேச போறோம். thermal stability வந்து எப்பவுமே யோசிச்சுக்கோங்க, bond strength, see bond strength increase ஆகும்போது, I'm going to write it here, when bond strength increases, bond strength increases, thermal stability increases. When the bond strength increases, thermal stability increases, which means bond strength increase இருக்கிறதுக்கு அது வந்து bond length கம்மியானதா bond strength increase ஆகும். Bond length should be decreases, then only bond strength will be increasing, right? So the order will be H2O is greater than, H2O will be greater than, one second. H2O will be greater than H2S, H2SC and H2TE. So this is the order of the particular thermostability of the hydrides. You just want to make a note of this is the order. Theriyala bond strength, bond length, thermostability and the concept illanalu, that is well and good if you know it. If you don't know also, like just have a note of this particular order. Okay, next one is the hydrides, next one is the acidity. So always you know that acidity means it is the ability of giving off the hydrogen, right? So எப்பவுமே யோசிச்சுக்கோங்க, bond length increase ஆகிற compoundக்கு ஈஸியா வந்து ஹைட்ரஜனை இல்ல ஈஸியா வந்து எலக்ட்ரான்ஸ், ஹைட்ரஜன் சொல்ல வேணாம், எலக்ட்ரான்ஸை நம்ம வந்து கொடுக்கறதுக்கு ஈஸியா இருக்கும். am I correct? இப்போ பாண்ட் லெங்த் இன்க்ரீஸ் ஆகிட்டே இருந்தேன்னு வச்சுக்கோங்களேன், அவங்க அந்த பாண்ட் லெங்த் இன்க்ரீஸ் ஆகும்போது அந்த பர்டிகுலர் எப்படி சொல்றது அந்த சைஸ் இன்க்ரீஸ் ஆகும்போது பாண்ட் லெங்த் இன்க்ரீஸ் ஆகுது. ரெண்டு காம்பவுண்ட் வருதுன்னா ஒரு காம்பவுண்டுக்கும் இன்னொரு காம்பவுண்டுக்கும் பெரிய சைஸ் ஆகும்போது அதுக்குள்ள இருக்கிற பாண்ட் லெங்த் இன்க்ரீஸ் ஆகும். அது இன்க்ரீஸ் ஆகுறேன்னா அங்க இருக்கிற எலக்ட்ரான்ஸ் வந்து நம்ம கொடுத்துட்டு இருக்கோம். It is easy to give that particular electron, which means whoever is having bond length more, that will be having the more ability or more, they will be having more acidic character. So bond length more சொல்லும்போது, see here இதில் எல்லாத்திலுமே hydrogen is a constant one, correct? இப்போ நம்ம ஹைட்ரஜனை பேஸ் வந்து நமக்கு bond length ஒண்ணுமே சொல்ல முடியாது, ஆமா தானே? ஆனா this particular elements other than hydrogen can determine the bond length. So you know thus tellurium will be having highest bond length because it is having more size, am I correct? So this will be having more acidity when compared to all these others. So this is the order of this particular acidity in the properties of the hydride. This is very important. So these are the hydride particular acidity order. So just want to have a note of it, like this is not that much important, this will be asking. Okay, next one. Okay, next one is the property, the reducing agent, reducing character. Always remember whichever is having the acidity character more, or else we can say that whichever is having more bond length, more the bond length, more will be the reducing character or reducing property. So as I told you, H2O will be having less than till the tellurium. Okay, this is the order of the reducing character also. You have to know all the increasing decreasing orders and all, what is the order of this particular hydrides, halogens, everything, but you don't want to know about why it is happening, and that is not required, but the order you have to make a note of it because that will be asking during the exams. Okay, next one is the reactivity towards the halogen, how the particular elements in the oxygen family, how they will be reacting with the which one, halogens. Okay, so these elements, in the elements எப்படி பண்ணுவாங்கன்னா, they will be reacting and they can form EX6, EX4, EX2. What are the three formation? I mean, they can form the compounds of ES6, EX4, EX2. And let me tell you one thing, my dear students, E means group 6 la இருக்கிற group 16 la வர எல்லா elementsum, and this X means it is halogens. Okay, it is halogens. So they can react and they will be forming this particular three series EX6, EX4 and EX2. Now coming to the stability of the halides, you know that fluorine minus will be having more stability than chlorine, then bromine and then iodine. Okay, next one is the oxides. Now this is also another important point. Oxygen, see, இப்போ நம்ம ஆக்சிஜனா இருந்து ஆக்சிஜனுக்கு வந்து they can react with another elements in the periodic table and they will be forming the oxides. So I repeat, oxygen க்கு என்ன பண்ண முடியும், they will be reacting with, ma'am, oxygen வந்து they will be reacting with the most of the elements in the periodic table to form the oxides. Oxides வந்து form பண்ணுவாங்க. எந்த மாதிரி இருக்கிற oxides, acidic oxides இருக்கு, நிறைய different types of oxides இருக்கு, உங்களுக்கே தெரியும் நிறைய different types of oxides இருக்குன்னு. எந்த மாதிரி இருக்கிற oxides, அதோட peculiarities எல்லாம் I will tell you, but I will tell you which are the things you have to specifically focus. அதுவும் நான் சொல்லி கொடுக்குறேன். ஓகேங்களா, சரி. So oxygen will be reacting, as I told you, oxygen will be reacting with this particular most of the elements in the periodic table and they will be forming the oxides. Now, in many of the cases, what happens means the elements can form more than 2 oxides. For example, N2O, NO, NO2 and all. Na? So, they will be actually, because of their widely in their, like, they will be having this formed oxides. For example, carbon monoxide, carbon dioxide. So, they can form more than one oxides. But what happens actually is, in the carbon monoxide, carbon dioxide different character. Carbon monoxide carbon dioxide same character. Correct தானே? Carbon monoxide carbon dioxide ஒரே character. CO and CO2 is the same character? No ma'am, they don't have the same character. அவங்களுக்கு same character இல்ல. ரெண்டு different ஆன gas. ஆமா தானே? So they won't be having the same character even though they are formed in the same element. Carbon and oxygen தான், ஆனா அவங்களுக்கு different properties தான் இருக்கும். So oxides, there are simple oxides and there are mixed oxides. Listen carefully, what is simple oxides and mixed oxide? They have single oxidation state. This is very important. The oxides which is having single, you know about the variable oxidation state and normal oxidation state, single oxidation state. So there are some elements which will be having variable oxidation state or more than one oxidation state, right? Correct? So especially with the D block elements, we will discuss that time of the D and F block elements. So they will be having variable oxidation state. So the simple ones are the one which won't be having the variable one. They will be having only single oxidation state. For example, this MgO, Al2O3 and all, they belongs to the P block elements and they will be having single oxidation state only. Clear? Clear everyone? Puriyada? Okay. Next one is mixed oxidation state சொல்லும்போது அவங்களுக்கு வந்து oxidation state வந்து more than இருக்கும். For example, இப்போ iron oxide வந்து Fe2O3 இருக்கு, FeO இருக்கு. So it's because of their variable oxidation state of the iron. Am I correct? So that is actually comes under the category of the mixed oxides. Clear everyone? Clear? Okay. Now, simple oxides சொல்றதே வந்து there we can divide it into acidic, basic, amphoteric and neutral. Okay, what are the 4 classification of the simple oxides? I will just tell you what is that. Avlodha. Okay, that nothing, that much is not required for you guys. Okay, so simple oxides are divided into acidic oxide, basic oxide, amphoteric oxides and neutral oxides. Simple oxide, I again repeating, acidic, basic, neutral and amphoteric. Okay, acidic oxides means, you know, acidic oxides, they will be combining with the water and they will be giving you like gives the property of the acid. Am I correct? Oxides are இருக்கும், acidic oxides are இருக்கும், அவங்க water கூட combine பண்ணி நமக்கு acid ஓட property தான் கிடைக்கும். And tell me what is acidic oxides? Acidic oxides அப்போ acidic in nature. Correct? And do you know what? Which elements will be forming usually acidic oxides? Non-metals will be forming. Listen carefully children, this is very important point also. Non-metal oxides are generally forming are generally acidic in nature. For example, CO2, SO2, NO2, all these are acidic in nature. So they will be reacting with the water and this acid rains and all, na? Acid rain எல்லாம் அப்படிதான் வருது. அவங்க வந்து அந்த இண்டஸ்ட்ரியில் இருக்கிற எல்லா கேஸையும் வந்து இந்த CO2, NO2 இருக்கிற எல்லா non-metal oxidesோட gases-ஐயும் வந்து they will be expelling to the atmosphere. And what happens means when the rain comes, அவங்க rain கூட mix பண்ணிட்டு கீழே வந்துரும். அதான் acidic rain சொல்றது. So what happens means when they mixed with the water, they got the properties of the acid. They will be having the property of the acid. Okay, so examples are SO2, Cl2O7, CO2, N2O5 are the examples of the acidic oxide. Acidic oxides are non-metal, will be combining with the oxygen. I guess you have learned that in the சின்ன கிளாஸ்ல நீங்க படிச்சிருக்கீங்க. 10th லலாம் you will be learning, not in the 10th also, 9th லலாம் படிச்சிருப்பீங்க. Okay, now basic oxide சொல்றது, basic oxide வந்து எப்படி இருக்குன்னா வாட்டர் கூட ரியாக்ட் பண்ணும்போது சேம் they will be showing the property of the base. See, when the oxides that give a base on the reaction with the water, or they will be showing the property of the base when they react with the water. Okay, so Na2O, CaO, barium oxide, all these are, see, basically all the basic oxides, metallic oxides are basic in nature. Metallic oxides are basic in nature. So when they react with this particular one, we will be getting the calcium oxide, which is a base. When they react with the water, they will be getting calcium hydroxide. And one more thing, this particular sodium hydroxide or calcium oxide or barium oxide and all, calcium, barium, sodium and all are metal. So metallic oxides are basic in nature. Non-metallic oxides are acidic in nature. Now amphoteric. Amphoteric means they will be having dual behavior. அங்கேயும் இருக்கும் இங்கேயும் இருக்கும். நீட் வேணான்னு இருக்கும், இன்ஜினியரிங் போகலாமா மெடிசின் போகலாமான்னு இருக்கும். கோட்டெல்லாம் போட்டு மெடிசின் போகலாமே நல்லா இருக்குன்னு இருக்கும். ஆனால் அந்த இன்ஜினியரிங் பசங்களெல்லாம் ஏதோ அந்த பர்டிகுலர் அவங்கள மெஷர் பண்ணுறதோ ஒன்று பேக்கில் தூக்கிட்டு இப்படி போவாங்கல்ல, அது பண்ணலாமே, அதுவும் நல்லாயிருக்கும். அப்படி தானே? லைக் நம்ம எல்லாருக்கும் இன்ஸ்ட்ரக்ஷன் கொடுக்கலாம், நல்லாயிருக்கும் இன்ஜினியரிங்கு. டாக்டர் சொல்லும்போது இல்லை எல்லாரையும் பேஷண்ட்ஸை வந்து ரொம்ப அக்கறையாக, ரொம்ப ஹாப்பியாக, ரொம்ப கைண்ட்ஃபுல்லாக பார்க்கலாம். ஸோ அதே மாதிரி தான் ரெண்டு கேரக்டரும் வேறு. உங்களை மாதிரி தான். இப்போ உங்களுக்கு அதுதான் ஞாபகம் இருக்கும், என்னடா நான் பண்ணட்டும், மெடிசின் போகிறதா இல்லை இன்ஜினியரிங் போகிறதா, அது ஒன்றுமே இல்லாமல் எங்கேருந்தோ வருவாங்க ஒரு யூஜி, ஆமாம் தானே, அது பண்ணுறதா, லைக் என்ன பண்ணுறது அப்படி யோசிப்பீங்க, ஆமாம் தானே, கரெக்டு தானே? ஸோ அதே மாதிரி தான் amphoteric oxide சொல்கிறது. some metal oxide exhibit which exhibit the dual character. Some metal oxide which exhibit the dual behavior or dual character and they show the characteristics of both acid as well as the base. Base ஓடதும் இருக்கும், கொஞ்சம் ஆசிடோடதும் இருக்கும். நம்ம சொல்லுவாங்கல்ல, எனக்கு அதுவும் பண்ணணும் இருக்கு. இந்த யூத் ஃபெஸ்டிவல் எல்லாம் those who are participating in the youth festival can relate this particularly. இந்த டான்ஸுக்கும் அவங்களோட பேர் கொடுத்துருப்பாங்க, பாட்டுக்கும் பேர் கொடுத்துருப்பாங்க. ஸோ நிறைய இடத்துக்கு அவங்க பேர் கொடுத்துருப்பாங்க. இப்போ இது இதில் போகிறது, இது ஏதாவது ஒன்று கலையணும், லைக் யூ ஹாவ் டு சாக்ரிஃபைஸ் ஒன் திங், ஒரு ப்ரோக்ராம் சாக்ரிஃபைஸும் பண்ணணும். ஸோ அது வேணுமா இது வேணுமா, அதே மாதிரி தான் amphoteric. They will be having the characters of both acidic and the basic also. Example is Al2O3, aluminum oxide. Now neutral oxides means அவங்களுக்கு வந்து ஒன்றுக்குமே இல்லாமல், இப்போ இந்த வீடியோ பார்க்குறவங்க இருக்கும், நான் என்ஜினியரும் ஆகலடா, எனக்கு என்ஜினியரும் முடியாது, எனக்கு மெடிசனும் படிக்க முடியாது, ஐயோ இது படித்ததுக்கு அப்புறம் இந்த 5 வருஷம் நான் மறுபடியும் அங்கே படிக்கணும், என்னாலலாம் முடியாது. ஸோ அந்த மாதிரி 2 கேட்டகரிஸ் இருக்கும். எனக்கு அதுவும் வேணாம் இதுவும் வேணாம், நான் ஏதாவது ஒரு யூஜி இல்லை ஏதாவது ஒரு கோர்ஸ் எடுத்துகிட்டு நான் அப்படியே ஒரு ஓரமாக போய்க்கிறேனே. இப்போ எனக்கு வந்து +2 பாஸ் ஆகிறதுக்கோ இல்லை 11th பாஸ் ஆகிறதுக்கோ நான் இந்த வீடியோ பார்த்துட்டு இருக்கேன், அப்படி இருக்கிற நிறைய பேர் இருக்கும்ல. ஸோ அந்த மாதிரி இருக்கிறதா நியூட்ரல். அங்கேயே வேணாம் எனக்கு இங்கேயே வேணாம் பண்ண விட்டுருங்க. Oxides that are neither acidic or basic are called as the neutral oxides, and such oxides are called as, which is they don't have the property, they are neither oxide nor basic also, they are called as the neutral oxides. Carbon monoxide, N2O are the examples. I'm telling you, not carbon dioxide. Carbon dioxide not comes under this category. Okay, this is very important also, children. Okay, the names are very important, neutral oxides. Next one is, so we have done with the group 13, 14 and all. I mean 13, 14 we didn't done it. We will be doing it boron and carbon family. We have done with the nitrogen family, oxygen family. Now we are going to have halogens. Halogens like fluorine, chlorine, bromine, எல்லாத்துக்குமே ஒரு வில்லனா இருக்கும்ல, ரொம்ப நெகட்டிவ் கேரக்டர் இருக்கிற மாதிரி இருக்கும். ஹாலோஜன்ஸ் சொல்லும்போது வந்துட்டாங்களா ரொம்ப நெகட்டிவா இருக்கீங்க அப்படி இருக்கிற மாதிரி ஒரு கேரக்டர் தான் ஹாலோஜன் சொல்றது, ரைட்? டோன்ட் யூ ஃபீல் லைக் தட்? உங்களுக்கு அப்படி ஃபீல் ஆகாதா? லைக் ஹாலோஜன் சொல்லும் போதே எனக்கெல்லாம் நான் படிக்கிற டைமில் 12th யூஜி எல்லாம் நான் கெமிஸ்ட்ரியில் யூஜி எல்லாம் பண்ணுற டைமில் ஹாலோஜன் வரும்போது ஏதாவது ஒரு எக்ஸப்ஷன் வரும், ஏதாவது ஒரு பிரச்சனை பண்ணிட்டு தான் அவங்க போவாங்க. அப்போது ஹாலோஜன் ஆட் பண்ணுறேன், வந்துடுச்சுடா ஹாலோஜன் ஆட் பண்ணிட்டாங்க, ஏதோ பிரச்சனை வரப்போகுது, ஏதோ ஒரு 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 சம்பவம் அங்கே நடக்க போகுது, அப்படி தானே இருக்கும். எனக்கு அப்படி தான் இருந்துருங்க. ஸோ ஃப்ளோரின், குளோரின், புரோமின், அயோடின் அண்ட் அஸ்டாட்டின். சி அஸ்டாட்டின் இஸ் ஆக்சுவலி இந்த ஒரு 4 பேர் மட்டும் நீங்கள் ரொம்ப என்ன சொல்கிறது ரொம்ப ஸ்பெசிஃபிக்காக படித்தா போதும். ஃப்ளோரின், குளோரின், புரோமின், அயோடின் அண்ட் ஃப்ரீ கிளாஸஸ் bring infinite attendance. This is actually an easy way, but I guess அந்த ட்ரிக்கு படிக்கிறத விட ஃப்ளோரின், குளோரின், புரோமின், அயோடின் ஈஸியாக நமக்கு ஞாபகம் வச்சுக்கலாம். Fluorine, chlorine, bromine, iodine. So these are the elements which comes under the category of halogen groups, and we are going to study about their occurrence, their atomic properties, their physical properties, and of course their chemical properties also. Okay, now first of all when we are checking okay, Now, while you're checking about the atomic properties, we will be discussing about them. Of course, we will be discussing about their electronic configuration and papo, covalent and ionic radii pati papo, ionization and enthalpy pati we will be discussing, electron gain and enthalpy pati we will be discussing, right? And distance, what are the distance, everything we will be discussing. And this enthalpy of dissociation also, like that we won't be discussing that much, because that is not that much important in terms of the NEET. So we will be discussing about the atomic property. So atomic property, you know the general electronic configuration of this particular p block element of halogen groups will be ns2np5. ns2np5. ns2, ma'am, it is ns2np5. Oh, here they have given it already. Okay. ns2np5, and the fluorine, chlorine, bromine, iodine electronic configuration they have given. And now we are going to look into the atomic radius. These are very simple, children. These are very simple. You know that what happens from the top to bottom, right? If you see the periodic table, if you well aware about the periodic table and their classification and their properties and all, easily you can understand this, right? From top to bottom, ma'am, மேல இருந்து கீழே வரும்போது elements வந்து அங்க இருந்து இங்க இருக்கிற elementsல வந்து size increase ஆயிடும், ma'am. Correct? So iodine will be having more size when compared to the fluorine, because of the addition of the N, principal quantum number. Number of shells increase ஆகிறதுனால என்ன ஆகிறது? Atomic size will be increasing from fluorine to iodine. Next one is atomic properties, ionization enthalpy. Ionization enthalpy. So ionization enthalpy, as I told you, நிறைய வாட்டி அதோட definitions கொடுத்திருக்கேன்ல, உங்களுக்கு போர் அடிக்க ஆரம்பிச்சிடும்ல, நீங்க வந்து ஸ்கிப் பண்ணி பார்க்க ஆரம்பிப்பேன். இப்போ இந்த போர்ஷனில் நான் மறுபடியும் ionization enthalpy கொடுத்துட்டேன்னா, correct? So ionization enthalpy சொல்றது top to bottom size increases, so ionization enthalpy decreases, right? So which means fluorine will be having more ionization enthalpy because they will be having less size. அவங்களுக்கு சின்ன சைஸா இருக்கும், அதனால ionization enthalpy என்னதா இருக்கும்? நிறைய வேணும், right? So fluorine is greater than, chlorine is greater than, bromine is greater than iodine. Due to the decrease in the size, removing electrons demand higher energy. So what happens means, no, decrease in the size. One second, children. Yes. See, during decrease in this, when the size decreases, what happens due to the decrease? One second. What happened to this? Due to the decrease in the size, the decrease in the size, the removing electrons demands higher energy. It's not lower energy, it's higher energy. They required, when the size decreases, what happens? They required higher energy. Size is less means more energy. I will write it here one more time, then it will be much more better here. One second. Ionization energy increases, or else I will start with the size. Atomic size decreases, ionization energy increases. So when atomic size decreases means, i.e. increases means, whichever is having less size, they will be having more ionization energy. So this will be the order: fluorine, chlorine, bromine, iodine. I hope it's clear. Correct? Now, atomic, next one is the electron gain enthalpy. Here, children, I have to tell you one thing. Electron gain enthalpy will be, okay. Now, electron gain enthalpy, நம்ம என்ன எக்ஸ்பெக்ட் பண்ணுவோம்னா, மேல இருந்து கீழே வரும்போது ionization enthalpy எப்படியோ அதே மாதிரி தான் இருக்கும். கம்மியாயிட்டு வரும். சைஸ் இன்க்ரீஸ் ஆகும்போது ஐஇ கம்மியாயிட்டு வரும். ஸோ வாட் வி ஹேவ் டிஸ்கஸ்ட், லைக் நம்ம என்ன நினைப்போங்கன்னா, ஓகே ஃப்ளோரின், குளோரின், ப்ரோமின், அயோடின் தானே நம்ம இது டிஸ்கஸ் பண்ணியிருக்கோம். எங்கன்னா அந்த இடத்துல பீரியாடிக் கிளாசிஃபிகேஷனில் ஃப்ளோரின், குளோரின், ப்ரோமின், அயோடின் இருக்குது. டாப் டு பாட்டம் வரும்போது அயனைசேஷன் எலக்ட்ரான் கெயின் என்தால்பி வந்து கம்மியாயிட்டு இருக்கும். Fluorine, chlorine, bromine, iodine. ஆனா இங்க ஒரு எக்ஸெப்ஷன்ஸ் நடக்குது. There is an exception here. When do you know what is that exception, children? See, fluorine, we expected the ionization electron gain enthalpy. Not ionization, children. Electron gain enthalpy, okay? So we expected the electron gain enthalpy like fluorine, chlorine, bromine, iodine. Correct? Fluorine நிறைய electron gain enthalpy இருக்கு. அதுக்கப்புறம் கம்மியாயிட்டு. This is what we expected. But this is very important question. This will ask you in the exams also, okay? Even with the nitrogen, phosphorus also we have discussed it, right? This is very important. So what happens here is, chlorine is greater than the fluorine. Chlorine is greater than the fluorine. So why chlorine is greater than the fluorine? I have discussed that in already. Fluorine is having less size. Am I correct? They already have the electron density also, right? They have their own electron density. Electron repulsion also will be there. So the outcoming electrons, they will be face a repulsion because of the less size. So when it comes to the fluorine and chlorine will be having more electron gain enthalpy rather compared to the fluorine. That is actually happens in the 3p and 2p, and we discussed that also, right? Correct. 3p will be having like more ionization, electron gain enthalpy. 3p orbitals will be 3p elements, or we can say that third period, the particular ones, the elements will be having more electron gain enthalpy when compared to the second one. For example, fluorine, chlorine, nitrogen, phosphorus, all this will be having these exceptions. Especially in the exam point of view, அவங்க வந்து ஆக்சிஜன் குளோரினோடது கண்டிப்பா கேட்பாங்க. ஐ மீன் ஆக்சிஜன் குளோரின் இல்ல, ஃப்ளோரின் குளோரினோடது கண்டிப்பா கேட்பாங்க. ஃப்ளோரின் குளோரினை கம்பேர் பண்ணும்போது குளோரினுக்கு தான் ஹை எலக்ட்ரான் கெயின் enthalpy. It is because fluorine ஓட size கம்மியா இருக்கு. So already electron density அங்க இருக்கு. சைஸ் கம்மியா இருக்கும்போது இருக்கிற எலக்ட்ரான்ஸே வந்து அப்படி இப்படி இருக்கும். ஸோ எலக்ட்ரான் டென்சிட்டி அதுக்குள்ள இருக்கு. ஸோ இன்னொரு எலக்ட்ரான் வராங்க, சரி என்ன எடுத்துக்கோங்கடா நானும் வரேன் உங்க செட்டுக்குன்னு சொல்லும்போது they already have that repulsion in them. So they are not like okay I don't want it, எனக்கு தேவையில்லை உங்களன்னு சொல்ற மாதிரி தான் இருக்கும். ஸோ அதனால தான் ஃப்ளோரினுக்கு கம்மியாகும், குளோரினுக்கு அதை விட அதிகமாகவும் இருக்கிறது. This is an exception case, please do note it out. Okay, now next see, due to the small size of the fluorine there are strong interelectronic repulsion in the relatively small 2b orbitals of the fluorine, and thus the incoming electron does not experience much attraction. They won't be having வாங்க வந்துக்கோ electrons அது பண்ண மாட்டாங்க fluorine. Okay, next one is the enthalpy of dissociation. I will just tell you this particular one. I will just tell you what it is, that's it. Okay, so enthalpy means what happens means here when the enthalpy of dissociation will be, it will be much more, the order will be, where is this, the order will be more for, the order will be more for chlorine, then comes the bromine, then fluorine, then iodine. Why fluorine is in the space in this particular, see, you don't just want to know about the order only, Cl2, Br2, F2, I2. This is the enthalpy of dissociation, how they will be dissociating, that is actually the enthalpy of dissociation. Okay, so chlorine, bromine, fluorine, iodine, because fluorine will be having very less size. Am I correct? So due to the small size of the fluorine, what happens means there will be more repulsion of the electrons, correct? So that is the reason why the fluorine will be having a weak F between the FF bond. There will be having a weak bond because already their size is small and they have this electrons also. So electrons அவங்க ரெண்டு பேருமே ரொம்ப பக்கத்துல இருப்பாங்க. ஸோ அவங்களுக்கே ஒரு ரிப்பல்ஷன் வந்துட்டு இருக்கும். ஸோ இன்னொரு ஃப்ளோரின் வரும்போது அந்த ரிப்பல்ஷன் அங்கேயே இருக்கும். ஸோ ரெண்டு ஸ்மால் சைஸ்ல இருக்கிற எலக்ட்ரான்ஸா ரிச்சா இருக்கிறது அவங்க ரெண்டு பேருமே ஜாயின் பண்ணும்போது அவங்களோட ரிப்பல்ஷன் அதிகமா இருக்கும். அந்த பாண்டோட வீக்கனிங், அந்த பாண்ட் பர்டிகுலர் எஃப் சிங்கிள் பாண்ட் எஃப் சொல்ற அந்த பாண்ட் வீக் ஆகிறதுக்கு சான்சஸ் அதிகமா இருக்கும். ஸோ தட்ஸ் வை தே கம்ஸ் அண்டர் திஸ் கேட்டகரி. Okay, you just want to note about this exception case only, chlorine, then bromine, then fluorine, then iodine. Okay, next one is the bond length. Bond length is almost, bond length you know that this is very easy. Bond length நம்ம size increase ஆகும்போது, இப்போ ரெண்டு fluorine எடுத்துக்கின்னு வச்சுக்கோங்களேன், you have taken 2 fluorine and you know this is the size of the fluorine. ஸோ அவங்க ரெண்டு பேரும் ஜாயின் பண்ணும்போது இவ்வளோதான் சைஸ் இருக்கும். ஆனால் குளோரின் எடுக்கும்போது இன்னும் பெருசாக இருக்கும், கரெக்ட்? ஸோ இது அப்போ சைஸ் இன்க்ரீஸ் ஆகுது. சைஸ் இன்க்ரீஸ் ஆகுறேன்னா சேம் எலிமெண்ட்ஸ்ல சைஸ் இன்க்ரீஸ் ஆகிட்டே வருதுன்னா அவனோட பாண்ட் லெங்த் என்னதான் இருக்கும், இன்க்ரீஸ் ஆகிடும், கரெக்ட்? ஸோ ஃப்ளோரின் தான் சின்ன சைஸ்ல இருக்கு, ஸோ தே வில் பி ஹேவிங் லெஸ் பாண்ட் லெங்த் தென் அதர்ஸ், chlorine, bromine and iodine. I hope this is also clear. Now physical propertiesல இன்னொன்று பார்க்குறேன்னா, listen carefully. All halogen exist in the diatomic molecules. They will be existing as the diatomic. Diatomic means X2, like F2, I2, Br2, like ways. Okay. Boiling in the melting point. This order also. This order. Okay. Boiling in the melting point order, both having like fluorine is lesser than, from top to bottom what happens, it increases. Fluorine is lesser than, chlorine is lesser than, bromine is lesser than the ionic. Boiling in melting point will be increases. Hydration energy we have discussed it. It is also having more. Which one will be having more hydration energy? Fluorine, then chlorine, then bromine, then iodine. Okay. Fluorine is a pale yellow gas, greenish yellow gas, and chlorine is green, yellow gas. And this bromine when we are considering, bromine is the liquid form, children. Bromine is the only liquid form in this non-metals. So bromine is actually the brown liquid, and the iodine is actually a dark violet solid. Okay, iodine is actually a dark violet solid. There is no such questions, like I didn't see any high questions which is asking like their property, I mean the colors and all. Like, yeah, fluorine and chlorine you can have a note of it. But again, bromine and all, it's very basic, you guys. உங்களுக்கு தெரிஞ்சிருக்கணும், ஆமா தானே? So fluorine and chlorine react with the water. They will be reacting with the water, and the bromine and the iodine are only sparingly soluble in the water. They won't be, they are just sparingly soluble in the water. Next one is the reactivity of this particular halogen family. Chemical reactivity, like reaction with the halogens, reaction with the oxygen, with the metals, and with other halogens also. So while we are telling about the reaction, first one with the reactivity through the halogens means they will be forming hydrogen halide, HCl, HBr, Hi, right? They will be forming hydrogen halide, and they will be having this formula. This H is hydrogen and this X is the halogen. Okay, so down the group, டாப்ல இருந்து கீழே வரும்போது ஹைட்ரஜன் கூட இருக்கிற ரியாக்டிவிட்டி என்ன ஆயிடும்? கம்மி ஆயிடும். So it will be HF will be more reactive, then Cl, then Br, then I. So F2 react violently, whereas I2 will be slow at room temperature. Clear, everyone? So halogens will be reacting with the hydrogen also. They will be forming hydrogen halides, and fluorine, chlorine, bromine, iodine, everything will be reacting. But what happens means, when we comes down from top to bottom, மேலிருந்து கீழே வரும்போது reactivity என்ன ஆயிடும்? கம்மி ஆயிடும். So fluorine வந்து நல்லா react ஆயிடும். But when it comes to the iodine, what happens? அவங்க கொஞ்சம் மெதுவாக தான் பண்ணுவாங்க. Okay. Next one is the hydrogen halide. The same thing, only their strength. HF, HCl, HBr. Of course, which one will be having more strength? HF will be having HI will be having more strength when compared to the all other things, because acidic strength, you know that they will be having those, we discussed that this particular one, right? Whichever is having more size, what happens? They will be easily give the electrons. So this will be having more, and this will be having the less one. Okay. Now, halogen oxide, chlorine, bromine and iodine form oxide, in which the oxidation state of this halogen will be vary from +1 to +7. This is very important. The oxidation state is +1 to +7. It will be varying, and higher oxidation state of the halogens tends to be more stable than the lower one. Higher oxidation state is more stable when compared to the lower one. Considering the kinetic and the thermodynamic factors, stability order of the oxides formed by the halogen will be bromine, chlorine and iodine. You just check this particular one only. First is bromine will be lesser than, chlorine will be lesser than iodine. Iodine will be having more stability order of the oxides. Clear, everyone? Here they will be having more stability order when we consider about this particular thermodynamically and this particular factors. When we are thermodynamically and kinetic factors, when we check it, it will be having, iodine will be having the stability order will be iodine first, then chlorine, then bromine. It will be having more stable with iodine, then chlorine, then bromine. Clear, everyone? Okay. Now, chlorine oxides is Cl2O, Cl2O2, Cl2O6 and Cl2O7. Highly reactive oxides agents are tend to explode. Those highly reactive agents, they will be exploring. That chlorine contained compounds will be, which are very highly reactive. They will be exploring also. And these are oxides. Chlorine, halogen, when they react with, especially chlorine, when they react with oxygen, what is happening here? Okay. Now, Cl2 is used as a bleaching agent for the paper pulp and the textiles and in the water treatment. So these are actually what they are using, what their uses and all. They are using in the bleaching agent. They are used as a bleaching agent and used as a paper pulp in the and textiles in the and in water in treatments. Next one is how they will be reacting. This particular halogens will be reacting with the metals. How halogens will be reacting with the metals? Of course, when they react, they will be forming the metal halides, not hydrates, halides. Metal or halides வந்து form ஆயிடும். ஆமாதானே? For example, M சொல்ற metal கூட react பண்ணும்போது என்ன fluorine வருதுன்னா metal chloride, correct? They will be reacting and they will be forming the metal halides. So general reactions will be when the halogens, when they react with the metal, they will be forming the particular metal halides. Whichever is the I is the stoichiometric value, whatever is the amount we are giving, Okay, now see Br2 when they react with the Mg. Mg is a metal, Br is an halides, they will be forming MgBr2. A Br2 when they react with the Mg, they will be forming MgBr2. Now their ionic character, we can see that Mf will be more than MCl, then Mbr, and then this will be Mi, children. Ionic character of MF will be more, because why ionic character? They will be having, they altogether they will be having less size, so they will be having more character, ionic character, MF, MCl, MBr, then Mi. Okay, M is actually a metal, monovalent metal. So if a metal exhibit more than one oxidation state, this is a very important point, children. If a metal exhibit more than one oxidation state, the halides in the higher oxidation state will be more covalent than one in the lower oxidation state. So whichever is more covalent or more ionic means when there is a halide compounds, halogen compound which is reacting and they are forming like a compound which is having metal halide, and that particular metal is having variable valency. Maybe they comes under the category of D block elements and all. So they have the variable valency. So in that case, we can say that the halides which is in the higher oxidation state, higher oxidation state la irukra halides da enada irukum, they will be more covalent. So if they have exhibit particular metal is exhibit, I repeat, if the particular metal is exhibiting more than one oxidation state, variable oxidation state, the halides which is in the higher oxidation state will be showing the covalent character than in the lower oxidation state. Okay, now so this is all about the halogens. Especially you have to check into this particular electron gain enthalpy and their reactivity. Avangaloda and the reactive electron gain enthalpy la vera change they will be asking you. And also ionization enthalpy பார்த்துக்கோங்க. அப்புறம் hydrides கூட இருக்கிற reactionsம் பார்த்துக்கோங்க. Okay, these are very important points which is comes to the halides. Now comes to the halogen groups. Okay, now comes to the noble gases. Noble gases means helium, neon, argon, krypton, xenon and radon are these are the available 6 noble gases: helium, neon, argon, krypton, xenon and radon. I repeat, helium, neon, argon, krypton, xenon and radon are the available 6 noble gases. Now, is there any point here? One second. Now, all these are gases and they are chemically unreactive. எல்லாமே gases தான், ஆனால் அவங்க அன்ரியாக்டிவ். அவங்களுக்கு வந்து அவங்களே ஸ்டேபிள் ஆகிட்டு இருக்காங்க. நான் எல்லாமே ஃபைனாக தான் இருக்குது, எனக்கு எந்த பிரச்சனையும் இல்லை, நான் யார்கிட்டையும் ரியாக்ட் பண்ணவும் போகிறேன். நீங்கள் வந்து என்னை வந்து நான் அமைதியாக உட்காரு, என்னை மட்டும் வந்துட்டு நீங்கள் வந்து இப்படி ஸ்க்ராச் பண்ணாமல் இருந்தால் போதும், நான் அமைதியாக உட்காருன்னு நினைக்கிறது. they are very unreactive. They form very few compounds, hence they are termed as noble gases. அவங்க பண்ணுவாங்க ரொம்ப நச வந்துட்டேன்னா அவங்க காம்பவுண்ட் ஃபார்ம் பண்ணுவாங்க, but very few compounds, and that is why they are called as noble gases. So their occurrence and isolations are telling this is like a kind of, you have to know just what is happening, that's it. Okay, so all noble gases will be present in the atmosphere. More will be the evidence of in air la more vandittu argon irukum, less vandu xenon irukum. Argon, neon, krypton, helium and xenon. This is the order of this particular noble gases evidence in the air. And especially ella noble gas, I told you all the noble gases will be coming in, or it will be presenting in the atmosphere, but radon is not present in the atmosphere. So this is actually the, I hope this clear, this will be the traces. Helium, the neon, helium, all those things are there. What are the gases, or what are the gases which is present in the atmosphere? Okay, composition. Next one is the atomic property. Now comes the electronic configuration and the atomic property. So electronic configuration, you can understand the electronic configuration. They will be having the NS2 NP6. NS2 will be completely filled, NP also, P block, P subshell also completely filled. And I want you to know that helium, the exception is there, helium is N1S2. Okay, they are S block, and they are like, since S is also completely filled, so that's why they are considered as the noble gases. Okay, their inactive nature are described as they completely filled electronic configuration. Since they have a completely filled electronic configuration, see எதுக்காக நம்ம வந்து இந்த ரியாக்ஷன் பண்ணணும், எனக்கு ஸ்டெபிலிட்டி கிடைக்கலடா, எனக்கு ஏதாவது பண்ணணும்டா, ஸ்டெபிலிட்டிக்கு வேணும்னு சொல்லிட்டு தான் நம்ம ரியாக்ஷன் பண்றோம். இவங்களுக்கு ஆல்ரெடி அது கிடைச்சிருக்கு, இவங்க எலக்ட்ரான்ஸ் எல்லாமே இருக்கு இவங்க ஷெல்ல, so they don't want to react. They have already they are filled electronic, completely filled electronic configuration. And so down the group, what happened to the atomic size when down the group atomic size increases due to the addition of the N, right? When the number of shells increases, atomic size increases, so shell increases, so of course helium will be less, then xenon will be more down the group. Next one is ionization enthalpy. Ionization enthalpy also down the group, what happens? It decreases. Ionization energy decreases because the size increases. So they don't want to give that much energy to give that electron, take that electron. But what happens means, even though the ionization energy is decreasing, they will be having that particular elements, they show high ionization energy. See, when comparing, they are decreasing, but they will be showing high ionization energy. Why high ionization energy? The reason is they are already stable. இப்போ வந்து ஒருத்தர் வந்து எடுக்கிறாங்க, டே எனக்கு இந்த எலக்ட்ரான் கூட சொல்லிட்டு இவங்க கூட கரெக்டாக இவங்க எல்லாமே ஸ்டேபிளாக இருக்காங்க. ஒருத்தர் வந்து கேட்குறேன்னா அவங்களுக்கு கஷ்டமா தானே இருக்கும். they won't allow to give it, right? So what happens means, எடுக்கிறவங்க நிறைய எனர்ஜி போட்டு கொடுக்கணும். So அந்த எனர்ஜியில் வேரியேஷன் தான் சொல்றது it's decreasing. It's not that the value is very less or something. They have to provide high ionization energy, but the value is decreasing. அவ்வளவுதான், அந்த வேரியேஷன் வந்து டிக்ரீஸ் ஆதான் போயிட்டு இருக்கும். Okay, due to the stable electronic configuration, they exhibit very high ionization energy. So but still I'm telling you, the value will be less decreasing. The value will be high, but it will be slowly when comparing the values, that will be decreasing down the group. Okay, helium will be more, then neon, argon, krypton and xenon. Okay, next one is the physical properties. All the noble gases are monoatomic. Why they are monoatomic? They don't want to join with anyone. They are stable. I'm perfect. That's it, right? So they are monoatomic. They are colorless, odorless and tasteless, and they are sparingly soluble in the water. They will be having very low boiling point and very low melting points, because they don't want to do any reactions, nothing is happening there, right? Because they are completely filled electrons, low melting point and boiling point. Because the only type of intraatomic interactions are the weak dispersion. Weak dispersion. This is because the only type of the only type of interatomic interaction is the weak dispersed force. So that is the reason why they don't have that much high melting point and boiling point. They will be having the weak forces only between them. So that is the reason why they have the low melting point and low boiling point. Low melting point and low boiling point, and also they are stable also. Next one is noble gases are less reactive due to the completely filled NS2NP6 electronic configuration, and they do have high ionization enthalpy and positive electron gain enthalpy. I told you what is positive electron gain enthalpy. In the periodic table we have discussed it. Electron gain enthalpy is positive, is the negative is the positive means they don't want to get electrons. எங்கிட்ட electrons கொண்டு வராதீங்க, எனக்கு வேணாம், போயிடுங்க, I don't want it. So ஏன் அவங்களுக்கு வேணாம் சொல்றாங்க? அவங்க ஆல்ரெடி ஃபீல்டா இருக்கு, மறுபடியும் வந்து கொடுக்கணும்னு இருக்கா. So they don't require that. So they are showing the positive electron gain enthalpy, which is in the high level. Okay, so more electrons are no thanks, I'm full. Okay, this is actually a funny one, like for little more engaging. எங்கேயாவது கொஞ்சம் போர் அடிக்கும், like you will be having this is a theory part now, so கொஞ்சம் கஷ்டமா தான் இருக்கும் அதனால. So uses of noble gases, helium is used in the filling balloons and in the cooled nuclear reactions and all. Neons is used in the fluorescent bulbs and the discharge tubes. Neon bulbs are there. Argon is used in the filling electrical bulb and in the arc weldings, and they are used in the electrical bulbs also. So these are the main uses of the particular noble gases. Now So, one second. So, these are the uses of the noble gases. Clear, everyone? Clear? Now, I want you to write some difference in the melting point. I will give the exactly like what is the melting point, boiling point, exceptions, because that will be asking sure for the exams. Okay. So, I want you guys to note it down as a short note or cheat note, whatever it is. Okay. So, we have discussed about the till, I guess we have discussed in this particular one, we discussed about the nitrogen only. Now, from nitrogen only we started. So, I will give you the, from nitrogen family, from, because carbon boron family and this particular one now, from the boron family and carbon family is having different properties. So, nitrogen is having different. So, from the nitrogen family, from the nitrogen family means all other thing except boron and carbon in the p block elements. Okay. So, from the nitrogen family, top to bottom size increases, boiling point increases. Okay. So, nitrogen and so boiling point increases. There is no exception. See there are some exceptions in the boiling point in the nitrogen and oxygen only. I'll tell you, I will write it, exceptions. Exceptions. Okay. First exception is in the nitrogen family, right? So, nitrogen family, we expected this particular one as nitrogen. What are the nitrogen? Phosphorus, arsenic, antimony, bismuth. So, we will be expecting is in the order from top to bottom. This is something we expected. Expected one. But what will be the actual one? This particular both ones now, they will be changing. So, it will be nitrogen will be the, phosphorus will be the, arsenic will be the, bismuth, then antimony. This is the first exception. Okay. This is the first exceptions for the boiling point in the nitrogen family. Now, now, next exception. This is the first exception which is comes under the category of the, this is the first exception which is comes under the category of the nitrogen one. Now, there is another exception. Next exception is in the oxygen family. Oxygen family. So, oxygen, what are the elements? Oxygen, sulfur, selenium, ammonium, tellurium. So, we expected this particular one same as that of the nitrogen family, because top to bottom it increases. This is what we are expecting. But here instead of that, what happens here is between the tellurium and polonium, there will be a change. Oxygen, sulfur, tellurium, polonium. So, this is the exception which is happening here. This is the exception first exception, and this is the second exception. Okay, and this particular one now, which for the fluorine, that is halogen family, and neon family, that is noble gas family, 18th group. I will write it as in the form of group, that will be much better. 17th group and 18th group. No exceptions. They don't have any exceptions. They will be just whatever it is, like from top to bottom, boiling point increases. So this is according to the boiling point for the from the nitrogen family, the boiling point. Okay, boiling point. Okay, next one is the melting point. Melting point. So melting points also, this particular halogens and 17th and 18th, no exceptions. So what is the general order? They will be just like boiling point, melting point will be increasing from top to bottom. From top to bottom, melting point increases. Okay, so this is the no exception cases. Now comes the exceptions. நம்மளோட ஹீரோ வராங்கடா, ஹீரோ வராங்க. First exception is, there is an exception in nitrogen family and there is an exception in the oxygen family also. Boron and carbon also have the exceptions, but we will discuss that in the next P block. I mean, and the boron carbon எடுக்கும்போது டைம்ல நம்ம அதில் explain பண்ணலாம். Okay, for the nitrogen family, so we expected, what will be expecting with nitrogen? You will be having nitrogen, phosphorus, arsenic, and bismuth. This is what we expect. Now, this is what we expect. But what happens here is, there will be a change like this, correct? Arsenic and bismuth, which we have discussed. Now, instead of this, it will be like nitrogen, phosphorus, bismuth, antimony, arsenic. So this is the exception. This is what the exception. Clear? This is for the nitrogen family. Okay. Next, coming to the oxygen family. Oxygen family. Oxygen, sulfur, selenium, tellurium, polonium. So we will be expecting this. This is the what we expected. Now, what is the exception? Oxygen, sulfur, selenium. Oxygen, sulfur, phosphorus, oxygen, sulfur, selenium, polonium, tellurium. Yes, write it much more better. Polonium, tellurium. So this is the exception. exception and expected and exception. You have to get an idea about it. Exception. This is expected. I have written here, one second. Exception. Okay. Exception. So this is the exceptions of the particular melting point and the boiling point in the nitrogen. You have the exceptions on the p block elements in the nitrogen and oxygen. Fluorine and the particular noble gas is not having that much exceptions in the boiling point and melting point. But again, coming to the boron and carbon family now, they have some other property. It's top to bottom. Nowadays we have discussed about the boiling point increases, but there it will be decreases. So that is having another property. So this is the property that is the expected one, and this is the this is where the difference happens. Okay, I hope this is clear. This is very important. So I guess this will make you a little more idea, and this will give you a little more idea on this particular topic. So melting point is boiling point is very, very important when considered with any other one, because they have a lot of exceptions on that. So surely they will ask it also. Okay, so I hope this session is clear. I didn't do any practice any aside. நான் எப்போவுமே சொல்கிற மாதிரி தான், நான் ப்ராக்டிஸ் கொஷின் எதுவுமே பண்ணல. நம்ம பண்ணுவோம். நம்ம எப்போ பண்ணுவோம்னா live session la we will do the practice question also. So be prepared with the theory first, then we can go for the practice questions. Okay, I hope in the chapter வந்து உங்களுக்கு ஒரு ஐடியா கிடைச்சிருக்கும். இதில் ஒரு ஒன் ஷார்ட்டாக நம்ம ஒரு 1.5 hours தான் இருக்கும். மேக்ஸிமம் 2 hours தான் இருக்கும். ஸோ இதிலிருந்து ஒரு ஐடியா கிடைச்சி ப்ராக்டிஸ் பண்ணிக்கோங்க. we can score easily. Okay, இப்படி படிச்சாதான் உங்களுக்கு ஸ்கோர் பண்ண முடியும். Okay, so this is all about the p block elements. இந்த வீடியோ பிடிச்சிருந்தேன்னா please do like the video, and இதே மாதிரி இருக்கிற கண்டென்ட் கிடைக்கணும்னா என்ன பண்ணணும், வெற்றி சேனல் நீங்கள் வந்து லைக் பண்ணணும். அண்ட் லைக் பண்ணுறதில்ல, சப்ஸ்கிரைப் பண்ணணும். ஸோ வெற்றி சேனல் சப்ஸ்கிரைப் பண்ணிக்கோங்க. அதே மாதிரி இந்த வீடியோவும் லைக் பண்ணிக்கோங்க. இனி எந்த டாபிக் வேணும், இஃப் யூ நீட் எனி டாபிக் ஸ்பெசிஃபிக்கலி, அந்த டாபிக் நீங்கள் கமெண்ட் பண்ணிக்கோங்க. ஐ வில் டூ தட் டாபிக் ஆல்சோ. ஓகே, ஸோ டாபிக் பேசிக்கலி சாப்டர், எந்த சாப்டர். இப்போ நான் ஒரு ஆர்டரில் போகிறேன், இஃப் யூ நீட் எனி ஸ்பெசிஃபிக் சாப்டர் ஃபர்ஸ்ட், மேம் ஐ நீட் திஸ் ஃபர்ஸ்ட், அப்படி ஏதாவது இருந்தேன்னா யூ கேன் டெல் மீ தட். அந்த சாப்டர் நம்ம ஃபர்ஸ்ட் எடுப்போம். ஓகே, ஸோ ஐ ஹோப் திஸ் செஷன் இஸ் clear for you. Any suggestions or anything I am open to any suggestions, any comments and all. Please do write down. Please do the comments whichever the chapter you need next, and also please do subscribe the channel for these types of amazing one shots of every chapter. Okay, thank you, bye bye.